Are you looking for a versatile programming language that can help you achieve your career goals? Look no further than Python. As a programming language that can help you land a high-paying job, Python serves as a great option. The Knowledge Academy provides you with the best opportunity to learn and implement Python through these free tutorials. So happy coding!
Today we will continue our practical code implementation on loops. The given code defines a function print diamond that generates a diamond pattern made of asterisks. The diamond pattern is symmetric and consists of rows in total. The function starts by iterating over the range from 0 to rows exclusive. For each iteration, it prints a line with a specific number of spaces and asterisks. The number of spaces before the asterisk is calculated as rows minus I minus 1 to create the left half of the diamond, where I represents the current row of the number. The number of asterisks in each row is 2 asterisk I plus 1, creating a symmetrical pattern. After the top half of the diamond, the function then creates in reverse order range rows minus 2 minus 1 minus 1 to print the bottom half of the diamond. The number of spaces and asterisks for each row in this phase is similar to the top half, but in reverse order, resulting in a complete diamond shape. Finally, the code calls the print diamond function with a parameter diamond rows set to 5, generating a diamond pattern with 5 rows in the top and bottom halves. In summary, this code leverages nested loops to construct a diamond pattern by adjusting the number of spaces and asterisks in each row, creating a visually appealing diamond shape. To generate a multiplication table using nested loops. Initialization. Rows and columns are set to 10, defining the dimensions of the multiplication table. Outer loop I. The outer loop controlled by I iterates from 1 to 10 inclusive. For each iteration of I, a new row is started in the multiplication table. Inner loop J. The inner loop controlled by J iterates from 1 to 10 inclusive for each value of I. For each iteration of J, the product of I and J is computed and printed, representing an entry in the multiplication table. The end t parameter ensures that the values are separated by the tabs. Printing the multiplication table. Within the inner loop, I asterisk j is printed following by a tab t to separate the values. After printing all columns for a particular row, values of I, a new line character is printed, print to move to the next row. By combining the outer and inner loops, this code generates a complete multiplication table with values representing the product of numbers from 1 to 10 in both the row and column dimensions. The end ensures the tabular alignment of the table, making it easier to read and interpret. Count the occurrences of each element in a list. The code counts the occurrences of each element in a given list. It initializes an empty dictionary, then it iterates through the list, incrementing the count for each element in the dictionary. If an element is encountered for the first time, it's added to the dictionary with a count of 1. If the element has been encountered before, its counted is incremented. Finally, it prints a dictionary where the key represents unique elements from the list and the corresponding values represent the count of each element. For instance, if the list contains 1, 2, 3, 1, 2, 1, 4, 5, 4, the output will display the counts of each element like 1 is to 3, 2 is to 2, 3 is to 1, 4 is to 2, 5 is to 1. Simulate a simple guessing game using a while loop. This code simulates a basic guessing game where the computer randomly selects a secret number between 1 to 100 and the player attempts to guess it. The program initializes a secret number using the random randit function and sets guess to false to start the game. The game is executed within a while loop that continues until the player correctly guesses the secret number. Guessed becomes true. The player enters their guess using the input function, and the program compares this guess with the secret number. If the guess matches the secret number, the program congratulates the player, sets guess to true, and exits the loop. If the guess is too high or too low, the program provides the feedback to the player and prompts them to try again. In summary, the player's objective is to discuss correct number within the given range, and the program guides the player with the feedback based on their guesses. Calculate the sum of even numbers and the sum of odd numbers within a given range. This code calculates the sum of even and odd numbers within a specified range, start range to end range. It initializes variable sum even and SUMOD to store the sum of even and odd numbers respectively. It then uses a for loop to iterate through the range, checking each number. If a number is even, checked using i%2 equals 0, it adds it to the sum even variable. If the number is odd, it adds it to the SUMOD variable. After the loop completes, it prints the sum of even numbers and the sum of odd numbers calculated during the iteration. This allows the program to showcase the total sum of even and odd numbers within the specified range. For instance, with start range is equal to 1 and end range is equal to 20, it will print the sum of even numbers and the sum of odd numbers from 1 to 20. Reverse a list in place using a for loop. This code reverses a list in place using a for loop. It initializes an original list and calculates its length. The for loop iterates up to the half of the length of the list. In each iteration, it swaps elements from the beginning and end of the list, effectively reversing it. The swapping is done by using tuple assignment, where elements are exchanged with their counterparts from the end of the list. For instance, in the first iteration, the first and last elements are swapped, and this process continues until the midpoint is reached. Finally, it prints the reversed list. The algorithm achieves the reversal in place, meaning it modifies the original list without creating a new one, providing an efficient way to reverse the elements within the list. Find and print prime numbers in a given range. This code identifies and prints prime numbers within a specified range. It defines a function is prime to check whether a given number is prime. The function returns false for numbers less than 2 as they are not prime. For numbers greater than or equal to 2, it iterates through numbers up to the square root of the input, checking for divisibility. If a divisor is found, the function returns false, otherwise it returns true. In the main part of the code, a specific range from start range to end range is specified. It iterates through this range and for each number calls the isPrime function. If the number is prime, it is printed as a prime number within the specified range. This code provides an efficient method to identify and display prime numbers in the given range, enhancing understanding of prime number identification and usage of functions in Python. Calculate the factorial of a number using a recursive function. This code calculates the factorial of a given number using a recursive function named factorial. Factorial is the product of an integer and all the integers below it down to 1. The factorial function employs a recursive approach. If the input number n is 0 or 1, it returns 1 as the base case. For any other positive integer, it recursively calls itself with n-1 until reaching the base case. Each recursive call multiplies the current number n with the factorial of the previous number, effectively calculating the factorial. In the main part of the code, an example number num is chosen, here 5. The factorial function is called with this number as an argument, and the result, which is the factorial of the given number, is printed. This code demonstrates the uses of recursive function to effectively compute the factorial of a number. Generate a list of random numbers and find the maximum and minimum values. This code generates a list of 10 random numbers between 1 and 100 using a list comprehension and the random randint function for the random value. It initializes an empty list called values and iterates 10 times, adding a random number to the list in each iteration. Once the list is generated, it uses the max and minimum function to find the maximum and minimum values within the list, respectively. The max function returns the largest value in the list, while the minimum function returns the smallest value. Finally, it prints the generated list of random values, the maximum value found in the list and the minimum value found in the list. This code demonstrates a simple way to generate random numbers, find their maximum and minimum, and present the results for analysis or further processing. Simulate a simple ATM cash withdrawal. This code simulates a simple ATM cash withdrawal process. It starts by setting an example account balance to 50,000. It uses a while loop to continuously prompt the user for a withdrawal amount until the user decides to exit by entering 0. Within the loop, the code first checks if the entered withdrawal amount is 0, indicating the user's desire to exit. If so, it prints a message and exits the loop, terminating the program. If the user requests a non-withdrawal amount, the code checks if the withdrawal amount is greater than the account balance. If the withdrawal amount exceeds the balance, it informs the user of insufficient funds and prompts for a smaller amount. If the withdrawal amount is within the available balance, it deducts the amount from the account balance, simulating a successful withdrawal and prints the updated balance. This code allows user to perform simulated withdrawals and appropriately manages their account balance, emulating a basic ATM transaction process. Print the Pascal triangle. This code generates and prints the Pascal's triangle up to a specified number of rows, num rows. The function generate Pascal triangle starts with the first row, which contains only the number 1. It then iterates from the second row to the specified number of rows. In each iteration, it calculates the next row based on the previous row by summing pairs of adjacent elements. The new row is appended to the triangle. The output loop controls the number of rows, and the inner loop calculates each row's elements based on the previous row. The result is a 2D list representing Pascal's triangle. After generating the triangle, the code prints it row by row, centering the elements to maintain a visually pleasing triangular shape. In summary, this code generates and displays Pascal's triangle, a mathematical pattern where each number is the sum of two numbers directly above it in the triangle, starting and ending with 1. In this code, it simulates a simple game of rock, paper, scissors between a user and computer. It first imports the random module to allow the computer to make random choice. The game operates in an infinite loop, prompting the user to enter their choice, rock, paper, or scissors. The user can also type exit to quit the game. The program validates the user's input and checks for a valid choice or an exit command. If the user's choice is valid, it randomly selects a choice for the computer. The user's choice and the computer's choice are then compared to determine the winner. The results are printed indicating whether it's a tie, the user wins, or the computer wins based on the rules of the game. This code demonstrates a basic interactive program and introduces concepts like user input, conditional statements, loops, and random selection. Calculate the square root of a number using Newton's method. This code implements Newton's method to calculate the square root of a given number. The method begins with an initial guess for the square root, iterating through refinements until the guess is accurate enough. The formula for each iteration is guess is equal to 0.5 star guess plus number by guess, where the guess is updated based on the difference between the square of the current guess and the target number, controlled by the specified tolerance. The loop continues until the absolute difference falls below the tolerance. In this specific example, the code calculates the square root of 25 using the square root Newton method function. The result is then printed, providing an approximate of the square root. Newton's method is an efficient iterative algorithm for approximating square roots and is widely used in numerical computing and optimization problems. Print a hollow square pattern. This code generates a square pattern using nested loops. The outer loop for I in range size controls the rows, while the inner loop for j in range size controls the columns. Each iteration prints an element based on the current row I and column j. For the first and last rows, when I double equal to 0 or I double equal to size minus 1, and the first and last columns when j double is equal to 0 or j double is equal to size minus 1, an asterisk is printed to form the outline of the square. For all other positions within the square, a space is printed to create the hollow effect. The end argument in the print function ensures that the elements are printed horizontally. The code then moves to a new line after each row by calling print without any arguments. This process continues for each row, ultimately forming a hollow square pattern using asterisks for the border and spaces for the interior, resulting in a visually appealing square shape. Simulate a basic dice rolling game. This code simulates a basic dice rolling game. It utilizes a while loop to continuously prompt the player to roll the dice until they decide to exit by typing no. In each iteration, the code asks the player if they want to roll the dice. If the player types yes, it generates a random dice value between 1 and 6 using random function. The result is then displayed to the player. If the player types no, the game exits and displays a thank you message. For any other input, it informs the player of an invalid input and prompts them to try again. This code allows the player to interactively simulate dice rolls and demonstrates the usage of loops, user input, conditional statements, and random number generation in a simple game context. Calculate the sum of squares for a given range of numbers. This code calculates the sum of squares for a specified range of numbers. It begins by defining the start and end of the range, inclusive. It then uses a list comprehension, iterating through the numbers in the specified range. For each number, it calculates its square I ** 2 and adds it to the list. After iterating through the entire range, it uses the sum function to calculate the sum of all the squares in the list, providing the total sum of squares for the given range. Finally, it prints the sum of squares. This approach efficiently utilizes the list comprehension to calculate and sum the squares, offering a concise way to Find the sum of squares for a specified numerical range. That's all for today. If you enjoyed this video, hit the like button and subscribe to the Knowledge Academy's YouTube channel for more exciting and informative content. Don't forget to turn on the notifications so you never miss an update.